So we were talking about what hypothesis is, okay? And
yes,
we said hypothesis is a guessculation, or it's a statement of fact which can be true or not. It's a conjecture.
so sorry, did you say a speculation?
Yeah. We can speculate. I can speculate that you're 48, you are 40 years old. Okay.
Okay.
You get it? If I say, because it's a conjecture. Once it's a conjecture, what it means is that if you are conjecturing, it means that we are making some sort of assumptions. Okay, so if I say you are 20 years and you are not 20 years, we need to test. Right? Or it's a claim that someone is making. So if I'm making a claim that, or I'm speculating, which is a claim that somebody, you are a pastor, or sorry, you are a thief, you understand? If I say that, it's a claim. That claim has to be what? Justified. You get it? It has to be tested, right? So for instance, we are saying that if a manufacturer of a rechargeable batteries claim that the batteries they produce are good for an average of at least 1,000 charges, a sample will be taken to test this claim. You get it? A sample will be taken to test this claim. So a verbal statement or claim about a population parameter is what we call statistical hypothesis. So to test the average of 1,000 hours of a pair of hypothesis of a pair of batteries, hypotheses are stated. Once that represents the claim and the other which is complementary. So if I make any claim, in order to state the hypothesis, I would have to make two statements. One is the claim and the other one that is complementary. All right. And when one of these hypotheses is false, the other one must be true. So once I say that you are a thief, for instance, or you're a pastor, for instance, it's a claim. But I need to now write this thing in two statements if I want to test it. That is the basis. That is what we do, or the kind of how do I put it? That is the structure, okay, that we use when we are testing for what hypothesis. Anytime you make a claim, that claim has to be supported with another complementary what? Claim. And then we take it up from there. So a null hypothesis, which is represented HO, is a statistical hypothesis that contains a statement of equality, such as less or equal to, or less or what? Less or equal to. Okay, that's what the null contains. The alternative hypothesis, the complementary of the null hypothesis, is a statement that must be true if HO is false. Okay, and contains a statement of what? Inequality, or such as what? Greater than, not equal to, or less than. So if I say that you are a pastor, okay? You are a pastor. In other words, I'm saying that Patricia is equal to what? A pastor, isn't it? I need to make another statement to indicate that Patricia is not what? A pastor. You get it?
A pastor, yeah.
You get it? So if I say Patricia is a thief, I need to make another statement that Patricia is not a thief. Anytime I want to test the hypothesis, right, I should have in mind that the null hypothesis has an what? Equality sign, and that the alternate hypothesis has what? An inequality what sign. Is that clear?
Yes, sir.
Okay, so to write a null and alternate hypothesis, translate the claim made about the population parameter from a verbal statement to what? A mathematical what? Statement. So let's look at it. So, example. Write a claim as a mathematical sentence. State the null and alternate hypothesis and identify which one represents what the claim. So, a manufacturer claimed that each rechargeable batteries have an average life of at least 1,000 watt charges. Have you seen? So,
yeah,
the population, it said rechargeable batteries, right? That is the population of what? Mu, okay? That is, has what? At least, the least is what? 1,000 charges.
1,000.
So, greater or equal to what? 1,000.
1,000.
That is the condition of inequality. Does that make sense?
Yes, it does.
Okay, at least. Now, what? So this is how we write it. So the null hypothesis is what? Mu is greater or equal to what? 1,000. That's the claim. Then the alternate hypothesis, let's go back, which has the sign of inequality. Have you seen the sign of inequality? That is what is represented here. Have you seen it? Complementary.
Yes.
Does that make sense?
Yes, it does.
Okay. So another one. Write a claim. Write the claim as a mathematical statistic, the null and alternate hypothesis, and identify the which represent the claim. Now, the State Valley College claims that 94% of their graduates find employment within 6 months of graduation. So P, that is the population, okay, is equal to what? 0.9.
94.
Okay, so you see the first one, we were dealing with what? Said the manufacturer claims that rechargeable batteries have an average life. Rechargeable batteries. That's why we use what? The mu to represent what? The population, right? Now this one, it says the State Villa College claims that 94% of their graduates, it is not entire graduates. You understand? It is a proportion of the the population, which is what? The P, which is the sample of what? The population. You get it? This is not the entire the population. So P is equal to 94%. But we say that this is the claim, and P is not equal to what? 94%. That is complementary. All right. So testing the errors.
So just a minute. So the H1 must always be the opposite of the H.
Exactly. Exactly. Okay.
Okay.
So when they ask you how is hypothesis tested, or they give you a statement and they say, write the null hypothesis. Right. They give you a statement and say, write the hypothesis. What they mean is that write the null and what? The alternate hypothesis.
Alternative.
Okay. So let's see, no matter which hypothesis represent the claim, always begin with the hypothesis, assuming that the null hypothesis is true. You get that?
It's true.
Assume that you are a pastor. Assume that you are a thief. You understand? That's what we want to, the assumption has to be made. Now, this is very important. At the end of the test, one of the two decisions will be made. Reject the null hypothesis or fail to reject the null.
Fail to reject.
Reject the null hypothesis or fail to reject. You didn't say that, you didn't see accept here. There was no accept. Have you seen it? Reject the null hypothesis or fail to reject the null hypothesis. Does it make sense?
It does, it does, it does.
Now let's look at what is type 1 error. A type 1 error occurs if the null hypothesis is rejected when it is true. In other words, you are a pastor, but we say that you are not. You are the thief, but they say you are not the thief. Because the null hypothesis says that the claim says that you are a pastor, isn't it?
Yes.
But now we say you are not. So when that incident happens, then we say that there is a type 1 error. You get it? Then we have a type 2 error, which occurs if the null hypothesis is not rejected when it's false. This time, you are not a pastor. You get it? You are not a pastor, but we say you are. You are supposed not to be a pastor. In other words, when we did the test, you are not a pastor, but we did not reject. Does that make sense?
Yeah.
So let's go over. A type 1 error occurs when a null hypothesis is rejected. You are a pastor, but we are saying that you are.
Yeah.
A type 2 occurs when the null hypothesis is not rejected, when it's true.
Rejected.
This time you are not a pastor, but we say you are. So this is what it is. Actual truth. Do not reject HO. C, correct decision. Type 1, what? Type 2 error. It said do not reject. It gives you what? A type 2. HO is false, but we say it's correct decision. Here, HO, type 1 error. It is correct decision, but we do what? We reject it.
Yes.
Does that make sense?
It does make sense.
An example. So, the state biller claims that 94% of their graduates find employment within 6 months of graduation. What will a type 1 or a type 2 error be? So you see, P is equal to 94. P is not equal to 94. That's the alternate, right? Now, a type 1 error is rejecting the null hypothesis, when it is true. In other words, the population proportion is actually 94, 0.94. It's 94%, but it is rejected. We believe that it is not. You get it? The second one, type 2 error, is failing to reject the null hypothesis when it is true. The population proportion is not 0.94. It's not 94%, but it is not rejected.
It's not rejected.
We believe that it is true. Does that make sense?
It does make sense.
Does it make sense?
It does. It makes sense. A lot of sense.
So hypothesis. Now something called significance level. And then you see this thing coming up most times, and people don't want to hear. So in hypothesis test, the significance level is your maximum allowable probability of making a type 1 error. Look at it. It is your maximum allowable probability of making a type 1 error. And a type 1 error is when a null hypothesis is rejected when it is true. You get it? So a type 1 error will happen, okay, when you set what? Your significance level. You get it?
Yes, sir.
So when we say significance level, it is the level at which you can commit a type 1 error. You get it? You get it? It is the level at which you will commit type 1 error. So let me ask you a question. If I have a level which is 10%, and a level which is 5%, and a level which is 1%, and this is the level of committing type 1 error, which of the levels will give a high error? And which one will give a low error? 10, 5, 1%. Which one?
10 will give a high level.
Exactly.
And then 1 will give a low level.
Fantastic. All right.
Yeah.
So that in research, when we set our significance level, it simply means that it is the error we can tolerate. In other words, it is the error that we can allow. Do you get it? So when we set 1% error or significance level, we are only saying that the probability of committing a type 1 error is just 1%. In other words, the confidence we have in the data is 99%. You get it?
Yeah.
So if our level of error is 5%, our confidence in the data is what? 95%. Okay? And if our error is what? 10%, our confidence in the data is what? 90%.
90.
You get it? So the lower the error, you understand, the level of what at which we minimize the error. The lower the significance level, the level at which what we minimize what the error. So when it is low, it means we have a lower probability of committing a type 1 error. Do you get it?
I do, sir.
So hypothesis tests are based on what? So we use this alpha to indicate a type 1 error and the beta to indicate what? A type 2 error. Right?
Yes.
Okay. So the common significance level is what you are seeing. 10, 5, and then 1%. Right?
Yeah.
So let's go. So after stating the null hypothesis and alternate hypothesis and specifying the significance level, a random sample is taken from the population and the sample statistics are calculated. The statistics that is compared with the parameter in the null hypothesis is called the test statistics. Okay, so let's watch something. We have, you see the mu, the population parameters. You had this, the mu, the p, and what? The alpha raised to the power 2. So this is what we call the test statistics. And this is the standard test for statistics. I don't want us to go into this. I want just to give you a clarity on this. So we have seen at least the p-value where it's coming from. All right? And the mu, where it's coming from. Now let's look at this. If the null hypothesis is true, the p-value or the probability value of the hypothesis test is the probability of obtaining a sample statistics with a value as extreme or more extreme than the one demanded from what? The sample data. Let's look at this. This is what it means. That's what it means. So p-value of the hypothesis test depends on the nature of the test. So let me give you an example. There are 3 types of tests. There is the left, the right, or the two-tailed test. The type of test depends on the region of the sample distribution and favors a rejection of HO. This region is indicated by the alternate hypothesis. So let's look at this. So if the alternate hypothesis contains less than equality symbol, the hypothesis test is a left tail test. Have you seen it? You see, greater than, look at here, less than, look at here. So we call this a left tail test. A left tail test. So we say that HO is, that the null is what? Greater or equal to K. But the alternate is what? Less than the opposite K. Of it. So we call this what? A left tail test. You might see this. So when they ask that, what is a left tail test? Okay, the one that has the inequality symbol of the alternate hypothesis as less than or greater than, as less than, okay, left tail is less than, right tail is what? Greater than. We'll come to the right tail. Okay, all right. So when they say what is a left tail test, it has what? The less than what symbol as part of the what? The statement made as the alternate hypothesis, right? Yeah. And then the other one is called the right tail test. Have you seen it?
Yes.
The right tail test. So that type of test that has the greater than okay, in the alternate what? Hypothesis, right? Statement. So then we have what? The two-tailed test. This one is how it looks like. So any test from the alternate hypothesis that uses the not equal sign is what? A two-tailed test, which has half of what? The left tail and half of what? The right tail. Okay. So in a two-tailed test, each tail has an area of what? Half. As opposed to what? This one that has what? The P. Okay. This P is the area to the right tail test, right? But here, the P is what? Half. And this place is also half. That gives you what? 1. Is that okay? So
yes,
if you generate any statistics and you see a two-tailed test, that is what actually it means. Okay? If you see a left-tailed test, a two-tailed test means that it used what? The not equal sign in testing the hypothesis. Okay?
Yes, sir.
So let's see. For example, for each claim, state the HO and HA, then determine whether the hypothesis test is a left-tailed or right-tailed or two-tailed. So let's look at this.
Okay.
A cigarette manufacturer claims that less than 1/8 of the US adults smoke cigarettes. Okay? So let's see. This has less than what? 1/2. So it says that 1/2 is what? 1 to 5. So it says less or what? Greater or equal to it. But the null is what? Left. Use what? The left tail. Have you seen it? We talked about it.
Yes, sir.
A local telephone company claims that an average length of a call is 8 minutes. So this is what? It's equal to, he said the length of the call is. So equal to what? 8. Then this is the two-tailed test. You get it. This one is not. So
yeah, two-tailed test, yes.
Okay. So what is the decision? The decision rule based on p-value. Okay. So to use the p-value to make the conclusion in what? A hypothesis, knowing that the p-value is the population what parameter, this one. All right? Is the population what parameter? You get it? So the value that the p-value will give us, okay, is what we compare with the significance level. You get it? The significance level is 0.1, is 0.01, 0.05, and what? 0.10. That is 1%, 5%, and 10%. Agreed? Agreed?
Yes.
Okay, so whatever value the P will give to us is what we compare with what? The significance level, to be able to ascertain whether the thing is significant at 5%, at 1%, or 10%. If it is at 1%, then it should be equal to 1 or lesser than 1. If it is at 5%, it should be equal to 5 or lesser than 5. If it is 10%, it should be equal to 10 or lesser than 10%. So if the significance level is 2%, then it is significant at 5%. If the significance level is 6%, it means that it is significant as what? 10%. If the significance level is less than 1%, it means it's significant at 1%. Does it make sense?
It does.
So there is it.
It does.
So decision rule based on the p-value. To use a p-value to make a conclusion in a hypothesis test, compare the p-value with what? Alpha. Right? Now, if p is less or equal to alpha, then reject what? Where alpha is the significance what level? In other words, this is what we are saying. If you do the test and P is equal to, okay, 0.04. And your alpha value, that's your significance level you are using. Your significance level, I just want to look for alpha. Yeah? And then your significance level is 0.05. You understand? Watch.
Yeah.
If this is the case, what we are saying is that the P value, the population parameter gave you 0.04. Okay? And the significance level is what? 0.01.
0.05.
So it says that if P is greater, is less or equal to what? The alpha.
Alpha.
Then reject what?
Then reject HO.
So this one will reject HO. Do you get it?
HO.
Now,
yes.
Let's do this. Now, if P is 0.6, if P is 0.6, then it's what? Is greater than, it said if P is greater than alpha, then fail to reject what? O. So this one we fail to what? Reject O.
Reject the O.
We fail to reject it. We will not reject it. So the statement we use in explaining this is reject, fail to reject in hypothesis. Reject, fail to reject. We don't say accept. Reject, fail to reject. Does that make sense?
Yes, sir.
Right? And you see, when you reject O, HO, you say that there is enough evidence to reject what? The claim. Okay? If do not reject O, he said there is not enough evidence to reject what? The claim. Okay? If the claim is HA, he said there is enough evidence to support what? The claim. It's the same as this. Instead of saying there is enough evidence to reject the claim, you will say that there is enough, this one is reject, HO. There is enough evidence to support what? The claim. That is when you decide to what? Accept what? HA. Okay? So, now watch this. Interpreting the decision. You perform a hypothesis test for the following claim. How should you interpret the decision if you reject HO? Now see how it goes. If you fail to reject HO, then the claim should be, claim is what? HO. A cigarette manufacturer claims that less than 1/8 of the US adult population smoke cigarettes. So the claim here is that if HO is rejected, okay, what happened? We say you should conclude there is sufficient evidence to indicate that the manufacturer claim
is false.
Is false. Look at here. Sufficient what? Evidence. They were not conclusive. It's very important. You know why they cannot be conclusive? Because what we are doing is at a significant level of what? 5%, 1%, and 10%. We have already predicted a margin of error that we can allow in our study. So you are not conclusive. You understand? Our confidence in the data is only 99% or 95% or what? 90%. So our margin of error, which is the significance level, is either 1%, 5%, or what? 10%. Always remember this. So they are saying that there is sufficient evidence to indicate that the manufacturer's claim is false. If you fail to reject HO, you should conclude there is not sufficient evidence to indicate that the manufacturer's claim is what? False.
It's false.
What you do to, interpret your decision. And this is very, very important. Okay? This is very, very important.
Yes, sir.
So what we have done is to just give a brief of research methodology, and also we have digested the issue of hypothesis. I believe that, hypothesis, which has been a kind of a monster chasing you every day, today you have really,
yes.
what we will say is that you have been
You
really
have decoded it.
Yes, you have really crashed it, and you should carry it on. It happens every day in our life. Any statement we make, we have to test it. The interesting thing about hypothesis is that the claim itself is not touched. You understand? We don't really test the claim. We test the alternate what? Hypothesis, the complementary one. We test. And it's the same thing. But when scientists, they are conducting their study, maybe they take some animals and they want to administer some medications on them. They will take the sample animal, they will not do anything to that animal. The one that they want to test, they will not do, they will leave him, or they will leave it. Rather, it is the other one that they will inject, and they will see the behavior of the other one. So two, one that is used for the test will not be touched. The other one that is complementary is actually the one that they will administer the medication. So it is the behavior of that one. If he behaves the same as the same animal, then it means that the medication is not working, right? So if he doesn't behave that and he behaves otherwise, then it means that the medication is working. You get it? So that's how that is the whole concept about what hypothesis, right? So thank you so much for your time. For this session, we'll pick another time to discuss other topics.